Chapter 5, exercises 5F, 5G, and 5H deal with concentration. And you know, concentration is an awful lot like density. It's the amount of stuff you have per given volume. And you guys know about concentration, you've done it your whole life. But now we're going to do some calculations with it. And there are so many different kinds of concentration units that you could use. Just about anything. Drops of food coloring per beaker. Drops of Mio per water bottle. So many different ones. The one that we're going to use most often in chemistry is molarity, which are moles per 1 liter. Okay? So, a quick note with units. We've dealt with a lot of M things, moles, molecules, and meters and molarity. Capital M stands for molarity, or moles per liter. Okay? A small m stands for meter. It also actually stands for something called molality that you don't have to worry about until Chem 116. Moles has a short hand of mole. Molarity has a shorthand of capital M. Meter has a shorthand of little m, and molecules has a shorthand of MOLEC. MOL can't stand for both moles and molecules and molarity, so you have to be careful to use the right units. So M over L is not molarity. That's what we're trying to get at, okay? So, let's take a look at a couple of problems. The way we always do, you're going to write them down, you're going to give them a try. After hitting pause, then you're going to come back and we're going to take a look at how these problems have to be worked. So, time for pausing. Pause. Alright, you're back. So, first time in this chapter that we have more than one number. And so we have to decide how we're going to do things. Well, concentration is the amount per volume. This is your volume. This is your amount. So we're going to make our own conversion factor here by taking the amount, 73 grams, and divide it by 813 milliliters. And that's really it, except that we always do the math to determine the denominator in terms of 1 milliliter. How many grams are in 1 milliliter? So, 73 divided by 813 is, to 2 sig figs, 0.090 grams per 1 milliliter. The calculator value is 0.0897908898. The problem will only have 2 sig figs, right? So these are the significant ones. Does that round up? Sure it does. So whenever we're counting, we say 89, the next word we say is 90, whenever we add one more to the last significant digit. So that's the concentration. If we have 73 grams poured in so that we have 813 milliliters, and we poured 1 milliliter of this solution out, and then let all the water evaporate, there would be 0.090 grams of the sodium chloride in it. Alright, so that's the first problem. They want to know not just generic concentration, but the actual molarity. When they say concentration, you can use any units you want. These are the simplest. Molarity means moles per liter. So you can take that original number, or you could take these two, wouldn't matter. Let's use what we have here. 90 grams per 1 milliliter. Now, if you don't know what the units of molarity are, you're in big trouble. but you know that. It's moles per liter. So the grams has to go to moles, and the milliliters in the denominator has to go to liters in the denominator. That should be a pretty simple business to do. We've already done that stuff from chapter 2 and from early chapter 5. Milliliters, liters. Okay, so now we're at grams per liter, and now we have to figure out grams to mole. How do you get from grams to mole? You better remember that that's periodic table stuff, right? Molar mass. So we're dealing with sodium chloride here. The sodium, there's 1, and it's 22.99 grams per mole. And the chlorine, there's 1 of them, and that's 35. Let's see what it is. I don't want to mix them up. And there's the sodium, 22.99. Chlorine is 35.453 grams per mole. Alright, so when I add those up to get the molar mass of the sodium chloride, I get 58.44 grams per mole. So that's the grams per 1 mole. So what goes on top, what goes on bottom? The 58.44 goes with the grams, and to get the units to cancel, grams has to go on the bottom. I'm not asking you to memorize how to do problems. I'm asking you to use conversion factors and canceling out your units to get what you need. So where are my units in the numerator? 1 times 1 times moles. What are my units in the denominator? 1 times liters times 1. That's moles per liter. Right there. Since that started with 2 sig figs, my answer will have 2. So 0.09 times 1,000 divided by 58.44, and I get 1.5 moles per liter, 1.5 molar. Okay? That's how you go about doing your business. Okay, so one last question here. How many moles are in this many milliliters of 0.123 molar KBr? Once again, we have 2 numbers, so which one will we start with here? Well, the important thing to know is that M and what that means. And you have to remember that, of course, what that means is 0.123 moles of the KBr per 1 liter. If we want to end up with moles as our answer, the moles has to be in the numerator. So we could start with this value right here, 0.123 moles in 1 liter. But we don't have 1 liter, do we? We have this many milliliters. So we would first convert to milliliters, and then multiply by this volume in milliliters, 57.3 milliliters. The milliliters cancel. Everything cancels except for moles, and we're done. Let the units tell you how to go about your business to get from the units you have to the units you want to finish up with. This is a 3 sig fig problem because each of these has 3 significant figures, except for the metric to metric, which is infinite. So 0.123 divided by 1,000 times 57.3 gives me 7.05 times 10 to the minus 3 moles. And that's all you need to say. I don't need to know that this is KBr. It's clear from the problem. Okay, we're going to be doing these kinds of calculations so often, so you have to be ready for them, which means practicing 5F, 5G, and 5H. Good luck.